Hi, how's it going? Welcome to Code with Z. In today's video, we gotta calculate the square root of a number. Why? Well, because that's what LeetCode 69 square root is asking us to do. As you can see, it says, given a non-negative integer x, return the square root of x rounded down to the nearest integer. The return integer should be non-negative as well, and here it clearly says that we must not use any built-in exponent function or operator. Alright, we're not gonna need them because the solution is really simple. So let's see how we can actually solve this. You see, every time we're given a number and we need to find the square root of that number, we can just have a spectrum of numbers like this. Now, what do I mean by this? Well, for example, if we were given 4, we can guarantee if we actually check the spectrum from 0 all the way to 4 itself, we're gonna find an answer. And as we all know, the square root of 4 is 2. So each time we're given a number, we're gonna be like, if we wanna find the square root of that number, we're gonna check all of the numbers from 0 all the way to the number that we were given, and we can guarantee that we can find an answer. Now, what do I mean by this? Well, let's check. We're given 4, right? So we're gonna look from 0 all the way to 4. We're gonna say, let's first check 0. We're gonna be like, 0 multiplied by 0, is it equal to 4? Not really. 0 multiplied by 0 is equal to 0. So this is not gonna be the answer. So we're gonna be like, all right, 0 is not the answer. Let's check the next one. The next one is 1. We're gonna be like, 1 multiplied by 1, is it equal to 4? Not really, it's equal to 1. So this is also not the answer. And then we're gonna move on to the next one, and then we're gonna be like, 2 multiplied by 2, is it equal to 4? Well, yeah, awesome. This is gonna be our answer. So the square root of 4 is 2. Now, what will happen if we have a number like 8? Because the square root of 8 is actually 2.6, so we don't have a direct number. So we gotta actually return the nearest integer to the answer, which is 2. All right, so we said we have 8. We know we should actually search from 0 all the way to 8 for our answer. So if we actually think about it, this is in a way a searching problem, because we're basically searching for the number that if we actually multiply it by itself, it's gonna give us this answer here, or it's gonna be the nearest integer to the answer. So this is basically a searching problem, and we can easily use binary search because it's one of the most efficient search algorithms out there. So we're gonna be like, we're gonna initialize two variables, left, and it's gonna be equal to 0. And then right, that's gonna be equal to our number that we were given, and that's gonna be 8. So left is equal to 0 and right is equal to 8. And then we're gonna calculate the middle number between them, that's gonna be 4. Then we're gonna grab this middle, multiply it by itself, and we're gonna check if it's gonna be equal to our answer or not. So we're gonna say, is 4 multiplied by 4 equal to 8? Now really, it's equal to 16. So this is not gonna be the answer. And we're gonna look for other answers. So we saw that 4 multiplied by 4 is 16, and because 16 is greater than 8, we know that we should actually look for smaller numbers. We know that 4 multiplied by 4 is greater than our answer, so we're definitely not gonna check 5 multiplied by 5 or 6 multiplied by 6. It doesn't make sense. So we gotta look for the answer here. So we're gonna be like, all right, we've already checked 4, and we know these are not gonna be our answers. So let's bring right to middle minus 1, because we've already checked middle, so we're gonna bring right to middle minus 1, and then we're gonna calculate our middle again. The middle between these two is gonna be 1. Why? Because 3 plus 0 divided by 2 is gonna be 1.5, and the nearest integer is gonna be 1. So now middle is 1. We're gonna check if 1 multiplied by 1 is equal to 8. Now really, it's equal to 1. So this is also not gonna be our answer. And we can see that middle multiplied by middle is smaller than our number. So we're definitely not gonna check 0 because we already know 1 is already small. So why even bother with 0? So we're gonna be like, all right, we know this is not gonna be the answer. So we're gonna move on to the next one, and we're gonna be like, all right, left should be equal to middle plus 1. So left is gonna come here, and then we're gonna calculate our middle again. 2 plus 3, that's equal to 5, and then we divide it by 2, that's gonna give us 2.5. Nearest rounded integer is gonna be 2, so that's gonna give us 2. Now middle is pointing to 2, so then we're gonna be like, middle multiplied by middle, is it equal to our number? Well, 2 multiplied by 2 is equal to 4, so now really, and middle multiplied by middle is actually smaller than the number that we were given, so we know we shouldn't check the previous numbers. So we're gonna be like, all right, let's look elsewhere. 2 multiplied by 2 is equal to 4, and 4 is smaller than 8. So we're gonna be like, left should be equal to middle plus 1, and that's gonna make left be equal to 3. Then we're gonna calculate the middle again. 3 plus 3, that's gonna give us 6, divided by 2, that's gonna give us 3. So middle is gonna be 3. We're gonna check if middle multiplied by middle, meaning 3 multiplied by 3 is equal to our number. Not really, it's equal to 9. So again, we don't have an answer. And we're going to be like, all right, 9 is greater than 8. So you have to look elsewhere. And because 9 is greater than 8, right should be equal to middle minus 1, like so. And when this happens, that means we basically don't have a direct answer. And that's again because the square root of 8 is equal to 2.6, and we don't have 2.6 here. So we're going to be like, if we don't find the answer, we're just going to return right, because 2 is the nearest rounded number to 8. And as you can see, the square root of 8 is 2.8. So if we find the answer, just like we saw in the previous examples, we're just going to return it. And if we don't, we're just going to return right, because right is always going to be equal to the nearest rounded number to our original answer. Now, let's code this in the simplest way possible. Alrighty, let's code this together. So as we saw, we're going to define a variable called left, and this is going to be equal to 0. And then we're going to have a variable called right, and this is going to be equal to x. So for example, if our x is 4, this is going to be equal to 4. And then we're going to say while left is smaller or equal to right. This is going to be the condition that we're going to keep on looping with. And as you saw in the slides, when this was broken and when left was actually greater than right, we stopped. Here we're going to be like, as long as this condition is true, we want to do the following. We're going to define a variable called mid, and this is going to be equal to math.floor, because we want to get the nearest rounded integer when we actually find the middle. So we're going to say left plus right divided by 2, like so. So for example, if our left is 2 and our right is 5, that's going to give us 7. And if we actually divide it by 2, that's going to give us 3.5. And we don't want 3.5, so we're going to get the floor of it, and that's going to be 3. Then we're going to be like, if middle multiplied by middle is actually equal to the number that we were given, just return middle, because that's our answer. And if that's not the case, meaning if middle multiplied by middle is greater than the number that we were given, we want to do the following. We're going to say, because middle multiplied by middle is greater than the number that we have, we know we shouldn't check any number that comes after middle, and we've already checked middle. So we're going to be like, bring right to middle minus 1. And this is going to make our code check the left spectrum of our numbers. And else we're going to do the opposite. We're going to say left is equal to middle plus 1, classic binary search. And if we didn't actually find the answer, we're just going to return right, just like we saw in the slides. Now, this is going to be all of our code. Let's run it and see if we're going to get accepted. And let me bring this up. And yep, we got accepted. That's awesome. Let's submit it and see if we're going to pass all of the test cases. And yep, that's awesome. Thanks for watching. Don't forget to like and subscribe, and keep on coding.